Hey guys, in this video we will be discussing the fundamental layout types in Android. We will cover the linear layout in this video and rest of the layouts in the next upcoming videos. Let's start with linear layout. This layout is like arranging element in a single line, either horizontally or vertically. Imagine it is a stacking blocks one after the another. Here is how it works. In the XML code, we have defined a linear layout and set it orientation. The orientation will be horizontal or vertical. Based on this, the arrangements will be changed. Then inside this linear layout, we have added our child elements. We can add any child elements like button, text views. In this case, we added the button view. So here in the linear layout, we have added two gravity attributes. The gravity layout underscore gravity, which represents for the layout gravity, and the attribute only having the gravity, which contains element gravity or content gravity. Like if we remove this line of code, it will not in center. And if we remove this line of code, the layout will be not in center. If you change the orientation horizontal to vertical, it will be like this. It will arrange the elements in the vertical order, changing back to horizontal. And there is another attribute called weight sum, which is the integer value. We can specify 3 here. In Android linear layout, the layout weight sum attribute is used to define the maximum weight sum. This attribute specifies the maximum weight sum of the child views that are used to distribute the remaining space in the layout. When we assign the weights to the child views using the layout weight attribute, the remaining space in the layout is distributed among these views based on their views. So if you see in this example, the linear layout has the weight sum of 3 and indicating that maximum weight sum for the child views are 3. Each of 3 buttons inside the linear layout has layout weight as 1. So they each take up an equal portion of the available spaces as the total weight sum is 3. If you change the weight sum to different value, the distribution of space among the child views will be adjusted accordingly. Like if we change to 4, it will be adjusted accordingly, and we can add here 0.5 and 0.5. While using the layout weight and weight sum, we need to make our layout width as 0 dB if we are using the horizontal orientation. And same as we need to make height as 0 dB if we are using the vertical orientation. So this is how the layout weight works. That's it guys. If you have any doubts, let me know in comments. We'll catch up on next video. Thank you. Don't forget to like, share and subscribe for more tutorials like this. Hey guys, welcome back to our channel. Today we're going to see about relative layout in Android app development. If you're new here, please check all other videos and support the channel if you really like it. If you not watched the linear layout video, please check it out. The link in the description and I will add the card button here. Now let's move on to the relative layout. Unlike linear layout, relative layout allows us to position views relative to each other or relative to the parent layout. In the XML code, we define a relative layout as a parent layout, and inside the child elements, we will use attributes like align parent top, align parent left, top, bottom to position our views relative to the parent or other views. So let's see how to create a simple UI like this using the relative layout only. Navigate to Android Studio and change the constraint layout to relative layout. Don't worry, we will see constraint layout in next upcoming videos. Once you change the relative layout, now we're going to add our first element text view and use a wrap content. Add some text. So here the app name is in center. We're going to do that first. Android use layout align parent top, which is boolean. By this we are specifying this text view will align top of this parent view. And next we need to make it as a center. Now we can use center, horizontal and true. This will make our text view as a center. So the next thing we need to create welcome and create another text view, just duplicating this text view. Just remove our extra parameters. Now here if you see, this welcome button is bottom to this app name and start of parent. So now we're going to do below we just need to specify this text view ID. We're not created yet, so we're going and creating one. Just copy the name and use it here. So it is coming to this bottom of this layout. And then we are using align parent start true, which specifying this should start to the parent. And we're just adding some padding for good looking UI and applying the same for the app name. Just duplicating this and same like start, it has to come to end also. So just giving parent end. So if you see this text has some background, it is like button, right? So to make this, we can change this text view to button if we want. It will be like this and we are just showing welcome buddy. Instead of giving padding, we can give margin which make the space outside. And then we need to add our logo. It's just an image view. We can specify Android SRC and our logo. And just for the differences, I'm adding background as a black color. And this logo should be in center of the screen. So we have something called center in parent, which will we make true. It will come to center. So the next thing only we have left is login button. So the same thing, we just copy the button attribute and instead of the parent end, it should be bottom, align parent bottom should be true, and we need to remove this layout below and we just need to center horizontally. So in this relative layout, we have learned about how parent top horizontal, how parent start end works. These are the basic UI things you need to know. In the upcoming videos, we will choose constraint layout, create a complex UI. That's it guys. If you have any doubts, let me know in comments. Don't forget to like, share and subscribe for more tutorials like this. See you in the next video. Thank you. Hey guys, welcome back to our channel. Today we're going to see about frame layout. A frame layout is a container which holds one or more views. It is like stacking them on top of each other. Think of a transparency sheet. The one on top is the one you see. So why we need to use frame layout? While it can technically holds multiple data, frame layouts shines for simple layouts with a single prominent view. It's great for image as a background, buttons on top of images, overlays and pop-ups. Positioning views with gravity. While you can only have one view truly visible, frame layout lets you control where it should appear within the frame. We can use gravity attribute to specify where it needs to be appear within the frame. Imagine gravity pulling the view to different sides like top, bottom, left, right and center. We can even combine them like center vertical to center the view vertically. Let's see a quick example with an image and a button. We set the image as a background and we will use layout gravity to align the button on top of image view. Navigate to Android Studio and change the parent layout to frame layout and create one image view. Okay, I created a image view with a default background and I used a scale type center crop to fill the image to the frame. And then I'm creating a button using wrap content having text. I created a button. Now we need to use our layout gravity attribute to control the gravity. So first thing we can use a center horizontal. One cool thing is we can use multiple values for this layout gravity. For example, we can also specify bottom, which make our button view to the bottom of the frame. Since our goal is to the top, we can make this to top. So like this, we can use the top, bottom, left, right and center and also a center vertical, center horizontal in the gravity attribute. So frame layout keeps things simple for basic layouts. Remember, it's best for one main view at a time. For more complex layouts with multiple overlapping views, we will explore constraint layouts in the upcoming video. That's it guys. If you have any doubts, queries, let me know in comments. We will catch up on next video. Thank you. Hey guys, welcome back to our channel. Today we're going to see about constraint layout in Android development. It is a powerful layout manager that made a revolution in the Android app design system. What is constraint layout? A constraint layout is a flexible layout manager that allows easily to create a complex UI designs. It is similar to relative layout. Constraint layout utilizes constraints to define the position and alignment of the UI element. With constraint layout, we can easily create a responsive UI that adapt to different screen sizes and orientations, making it a go-to choice for modern app development. Now let's dive into the practical example of using constraint layout. Head over to the Android Studio. If you create any new XML, by default, the parent layout is a constraint layout. If it is not a constraint layout, feel free to change to constraint layout. And inside, we're going to add a button. To follow the best standards, we need to add the Android ID for each element we are using inside the constraint layout. And here, if you see, there is a red mark here which saying the view is not constrained, which means we not added any constraint related attributes to position this element. Now let's add some constraint. Type app colon. We need to import the app. Head over to the app. Click on option enter or control enter. And if you see, there will be added something called autores. Type layout underscore constraint. First thing, we need to plan where we need to show this top button. We just need to show this top button to the center of the parent. So we can just specify start underscore to start off, and here just add parent. If you see, as soon as we add it, this element will start to the parent. Now we need to specify, like start, we have something called end. We need to use end to end of parent, which makes our UI horizontally centered. Similar like start end, there is something called top and bottom. We need to use same, just to type top to top and select this and same parent, and again bottom to bottom, same parent. So now this element becomes in center. Now we will create another button, same button, wrap content, and in this the text will be bottom button, give ID also. Now we need to make this button bottom of this top button. Okay, how we will do this is, we have something called top to bottom of constraint top is belongs to this element, and the to bottom of is belongs to end element. Like we just specify this, and if we give parent, it will be go bottom to the parent. If we give some ID and referring to this top button ID, which make our element bottom of this top button. And again we can just specify start and end to center, start to start of parent and end to end of parent. So these constraints will ensure that these buttons stay fixed at their respective positions regardless of screen sizes and orientation. So this is a simple example showcasing the power and flexibility of constraint layout in Android development. We will see about guidelines and change in the constraint layout in the upcoming videos. That's it for this video. If you have any doubts, let me know in comment. We'll catch up on next video. Thank you. Hey guys, welcome back to our YouTube channel. Today we are going to focus on constraint layout in Android app development and specifically constraint guidelines. For your information, we are in Android UI XML series and this is the second video of the constraint layout. And if you are new here, please check it out the previous videos, link in the description and card button. Okay, let's start. So what exactly is a guideline in constraint layout? Well, think of a guideline as an invisible line that helps you position UI element with a constraint layout. It's incredibly useful for creating flexible and responsive layouts. Let's jump into some code to see how it works in action. Head over to Android Studio. This is where we left in the previous video. I'm just creating a guideline component. just give width and height as a wrap content. And as usual, we're just specifying the Android ID as a guideline. Now we need to specify two things. One is orientation and another one is guide percentage. So first we will specify the orientation. It will be vertical and percent. Here we can select the guide percent and it is a float value. We just specify 0.3. Here, by adjusting this percentage, we can control the position of the guideline dynamically. So basically, this will take a 30 percentage from the screen. Since we are giving the orientation as a vertical, it will take from start left to right and 30 percentage of the screen. If we making this to horizontal, it will take top to bottom of the 30 percentage of the screen. And just changing back to vertical. We can align UI elements such as buttons to this guideline using constraint. For example, like here we have a start to start of parent. Instead of parent, we just need to add ID and here we need to specify our guideline ID. And same thing we can also specify for this here. This allows them to adapt to different screen sizes and orientation seamlessly. To check how this will be in for tablets and different screens, just click on layout validation. If you're not having here, head over to these three dots and the layout validation will be here. So if you see here, since we are giving the percentage as a 0.3, it will always start 30 percentage of each screen. We also have something called guide begin. Here we need to specify the values in dimensions. So I'm giving 50 dp. So if you see here, it will take 50 dp. Different screens have different distance of 50 dB. In most cases, if we want to develop a responsive UI, we need to use percent and we can specify 0.7 here to see how it looks like here. Changing back to 3. And there you have it. With Guideline, we have a power to create a versatile and responsive layouts like this. Thanks for tuning in. Don't forget to like, subscribe and hit the notification bell for more coding tips and tutorials. That's it guys. If you have any doubt, let me know in comments. We'll see you on next video. Bye. Hey guys, welcome back to our YouTube channel. Today we are going to explore a powerful feature in the constraint layout called constraint chains. For your information, we are in the Android UI XML series and this is the third video about constraint layout. And if you're new here, feel free to check it out the previous videos, link in the description and card button. So what exactly are constraint chains? Imagine you have a set of UI elements that you want to arrange in a row or column, but you want them to behave as a single entity. That's where constraint chains come into play. So basically, it is a way to group UI elements together and allowing them to a single entity within a constraint layout. This is mostly useful for creating dynamic and responsive layouts. Let's dive into some code to see how we can create and use constraint chains. Head into the Android Studio and here is the where we left from the previous video. Here is a simple constraint layout with two buttons arranged vertically. By default, they are independent of each other. Now let's see how to create a chains for these two elements. Just drag into this elements to select it, or you can select by clicking command in Mac and control in Windows. Just select and click on right click, select chain. Since our elements are arranged in vertically, we can use vertical chains. So as soon as we selected, it is grouped and arranged. So if you see the code, there is something added called horizontal bias, which is used for the chains. So by default, the chain style will be spread. So the views are evenly spaced out once margin are considered. This is the default behavior. Okay. So we have multiple chain styles. We will try to explore that. Right click, same select the UI element and right click and go to the chains and vertical chain style. There is something called spread inside packer. So by default is spread, whatever we seen just before. Now we will just click on spread inside. Since we only have two elements, it is arranged to end of the chains. Now the next thing we need to see is packed. just to select both elements and right click, change style. If you click on pack, so as soon as we click, the views are tightly packed together once the margin are considered. So this is how the packed change style works. And that's it guys. If you want me to make a complex user interface with constraint layout, tell me what you want, or share the Figma or UI link in the comment or the Instagram, and I will make a video about that. And thanks for tuning in. Don't forget to like, subscribe, and hit the notification bell for more coding tips and tutorials. If you have any doubts, let me know in comments. We'll see you on next video. Bye.